Alright, we have a system of equations here, which means that we have two equations that both have to be true. And of course, for each equation there's going to be an infinite number of solutions, but there's probably only one solution that will make both of these true at the same time. We're going to try the elimination method here. Now the elimination method comes from the fact that you can add or subtract the same thing to both sides of an equation. So let's say we have 7x plus 6y equals 59. And say we want to add negative 14 to both sides. So on this side I'm going to subtract 14, and on this side I'm going to subtract 14, but instead of writing negative 14, I'm going to write plus 2x minus 6y. And the reason I'm going to do that is because 2x minus 6y is equal to the negative 14, so we can just subtract negative 14 by adding negative 14, or 2x minus 6y. And the advantage of doing this is that when I do it, this 6y will cancel with this 6y, giving me 0, and I'll just have 7x plus 2x, so 9x equals, and then 59 minus 14. 59 minus 14 is going to be 45, and that'll tell me that x is equal to 5. There we go. Now, if x is equal to 5, I know that 7x plus 6y is 59, so 7 times 5 plus 6y is 59, or 35 plus 6y. And 59 minus 35, I'm just going to subtract 35 from both sides of the equation here, and that gives me 24. So now I know that y, let me just go to a new cleaner piece of paper here. Now I know that y is equal to 4. So my solution is 5 for x and 4 for y. Now I can go in and check and make sure both of these are true. 7 times 5 is 35, plus 6 times 4 is 24. 35 plus 24 is 59, that's correct. And 2 times 5 is 10, minus 6 times 4, minus 24. So we got 10 minus 24, and that is negative 14, so that's correct. So that's how you do elimination. You just add two equations together. In this case, we took the equation 7x plus 6y equals 59, and 2x minus 6y equals negative 14, and we just made sure that the equal signs were aligned. And then you can set it up like this, like we used to have our old addition problems in arithmetic. And you just add each line by line. 59 minus 14 is 45. 6y minus 6y is 0. 7x plus 2x is 9x. So that's the elimination method. It's that simple. Now, elimination isn't always going to be this easy. Why not? Well, because we started out having coefficients of y that were exactly opposite of each other. Wasn't that convenient? Because that allows us to just add the two equations together and suddenly these cancel. Well, things aren't always going to be that easy. Sometimes it'll be a little more complicated than that. So let's look at another situation. Alright, so here I've got a system of equations where these coefficients are not the same, and this will be a little bit more complicated. I could actually solve this by substitution or by elimination if I want. In fact, any equation can be solved by either method. It's just that sometimes one is easier than the other. In this case, let's try to see if we can solve it by elimination. I want to have either my x coefficients be opposite or my y coefficients be opposite, so that I can add the two equations together. So I'm going to try to eliminate y here, partly because I like x better than y, so I want to keep x, and partly because the signs are already opposite, even if the magnitudes are different. So in order to eliminate y, I'm going to have to find a least common multiple. In this case, it's 12. So if I can multiply everything here by 3 and multiply everything here by 2, that should give me the equations that will work. So if this equation is true, we should be able to multiply everything by 3 and get an equation that's still true. So 9x plus 12y equals, let's see, 45. And then if this equation is true, we should be able to multiply everything by 2 and get an equation that's still true. So 4x minus 12y equals negative 8. All right. Now I'm going to add these together, just like in addition. And on one side of the equation, I'm going to be subtracting 8. So I got 45 minus 8 is 37. And on the other side of the equation, it doesn't look like it, but I'm subtracting 8. I'm subtracting 8 on this side of the equation too, because 4x minus 12y is negative 8, and I'm adding negative 8 to this side of the equation. So I really am doing the same thing to both sides of the equation, even if it looks completely different. So we've got 12y minus 12y is 0, and 9x plus 4x is 13x. So 13x plus 0 is 37. X is 37 over 13. Now that I know what the x is 37 over 13, I can just plug this value into either one of the equations. How about this one on the bottom here? And I get 2 times whatever x is, in this case 37 over 13, minus 6y equals negative 4. So 2 times 37 over 13 is 74 over 13, minus 6y equals negative 4. I'm going to add 74 over 13 to both sides. And let's see, we've got negative, that'll give me negative 6y is equal to negative 4 minus 74 over 13. And negative 4 can be written as negative 52 over 13. Whoops, I'm sorry, I just noticed you couldn't see that on the bottom, so let me rewrite it. 6y equals 52 over 13 plus 74 over 13. I just canceled all these negatives here. And now we can just add 52 and 74 to get 6y equals 126 over 13, or y equals 126 divided by 6 is 21, so 21 over 13. So our final solution would be 37 over 13, 21 over 13. And we can plug both of these values into both of these equations and check and make sure they're true. I do that in the substitution method video. I actually use the same equation as an example. So you can go ahead and check that one out if you want. Alright, so that's the elimination method. We just add the two equations together and eliminate one of the variables. And if that doesn't work, we'll mess around with some of the equations first to make it work. So thanks for watching.